Okay. All right, so number 10, starting with that is a log problem. This one's really important for the algebra piece. So first thing I do is I notice it's subtraction. Subtraction is division again. So log base 4, the first log goes on the top. The second log goes on the bottom. Okay, now this one is different from number 9 because this side does not have a log in the front, which means you need to do the loop-de-loop part. So make your loop-de-loop. 4 to the third power equals x over x minus 2. Four to the third power is 64, right? Anybody? 64 equals x over x minus 2. Okay, and then I'm going to put the 64 over 1 and cross multiply. So 64 times x minus 2, make sure to put that in parentheses. We're going to distribute equals x times 1 is x. 6x minus 12 equals x. What's wrong? No, yeah. Oh man, I didn't need, I could have made that 128. Thank goodness you're here. Okay. Good. Are you guys okay? Now, all right. Am I okay is really the question. All right. Anyway, minus 64x from both sides. Okay. Now, in case you have not learned this yet, maybe you have. I'm not sure if Miss Rice showed you my patented cheating method. It's not really cheating. I am going to reduce this fraction in my calculator. So I'm going to go 128 divided by 63, and I get a horrible, gross, disgusting decimal. Bad. Okay, and then what I'm going to do is I'm going to push the math button. The math button seems to be where everything lives in this calculator. And the very first thing says, hey, do you want me to change it to a fraction? Yes, yes, I do. Enter, enter. And it tells me that 128 over 63 is the reduced form. You can't reduce it any more than that. Okay, now this is kind of sad because and you can round it. We round these a lot. I'm going to leave it like this because I need to plug it back in to see if it works, and I want to leave it exact. So I'm going to go math log base 4, and then in this spot, I'm going to be really lazy, and I'm going to scroll up and highlight that and hit enter, and it will copy and paste it into my parentheses. Minus math log base 4 of that horrible fraction minus 2. And what do I want this stuff to equal if I did it correctly? 3. So, moment of truth. Ah, excellent. And then I just put my little note that I checked my answer. Okay, let me show you my patented trick again. So let's say I have something like 402 divided by 84, and I get a gross decimal. And then I go math, enter, enter, and it will reduce the fraction for me. I don't even have to think about it. Glorious, glorious reducing. Okay. All right, now let's do number 11 and 13. And you guys know you have a quiz tomorrow. These two problems will help you with some of that. So let's do these. And they're very quick. Sketch the general function, state the degree, and describe the end behavior. Okay, so on a problem like this, I'm going to say the degree first. The degree of this problem is 2 because 2 is the highest exponent. And this particular problem has a negative a value, which means there's a negative in the front. So I need my sketch to have 2 directions, and I need it to be pointing down because it's an even degree that's pointing down. So like this, 2 directions pointing down because a is negative. Okay, now this is the bit that we usually have typed in there for you, and usually you guys only have to fill in the blank. The top line is the left arrow, and the bottom line is the right arrow. And the left arrow is going down, and the right arrow is going down. Okay, and that's it. Number 13. So I want to try to show 11 and 13 kind of next to each other, the difference between them. This is degree 3, highest exponent, and a is positive. Okay, what does it mean when a is positive with an odd degree? It means that it's increasing over time. So I want 3 directions, and I want it to increase over time. So I'm going to go 1, 2, 3. Okay, so there's the bit that's usually printed for you. The top line is the left arrow, which is going down, and the bottom line is the right arrow, which is going up. Okay, scoot your packet over to the side. And on number 72, which hopefully you have sketched already, I'm going to use 2 colors. I'm going to use my original color and a color to mark the roots. So if you have another color, grab one. If you don't, no big deal. It's up to you. The goal of these is basically to work backwards from what we just did in the warm-ups. We're going to state the degree, state if A is positive or negative, and describe the roots. Okay. So first thing I'm going to ask you is for A, what is the degree for A? 2. Why is it degree 2? 1, 2. Okay. Both arrows are pointing up, so is A positive or negative? A is positive. Okay. Mark the roots. Now, if something's degree 2, it needs to have 2 roots. That's a rule. It has to. Degree 2 has to have 2 roots. What kind are these? Single. Okay, so you're going to say 2 single real roots. How do you know they're real? Because you can see the dots on the x-axis. You have them, you actually made dots. That means they're real dots. Why are they single? Because it's not a bounce or an inflection point. It just passed through. Okay, so you know you did it right because if it's degree 2, there should be 2. Okay, these are kind of quick. They're almost take longer to sketch than they do to actually do the problem. Okay, B. What degree is B? 3. 1, 2, 3. Is A positive or negative? Positive. And remember, when you have an odd degree, when one arrow is up and one arrow is down, you're looking to see if it's increasing over time or decreasing over time. Okay, now grab your other color. This one has 3 single real roots. Does that make sense to your brain? Okay, C. What's the degree of C? Is A positive or negative? Positive. It's opening upward. Okay, now I'm going along the x-axis and there isn't anything. That means that my roots are imaginary, but we're going to say complex. So 2 single complex roots. There has to be 2 because my degree is 2. So they have to be complex. All you have to do is subtract. I have a degree 2. There's 0 of them on the x-axis. 2 minus 0 is 2. Okay, last one. What degree is this one? Degree 3. Is A positive or negative? Negative because it's going decreasing over time. Okay, now get out your other color. We have 1 single real root. How many roots does there have to be though? 3. So the other 2 have to be complex. 2 single complex roots. And you might think to yourself, why is it single, Mrs. Talbot? That looks like it might look like a bounce. No. Remember about the plus or minus in the quad formula and or square rooting both sides. One of them's positive, one of them's negative. Did anybody have that question? I'm hoping somebody had that question. Okay. Anything that you need to want to ask about number 72 before we move on? You guys good? Okay, I'm going to give you time to sketch number 73. This is the last one that has all this art business. The other 2 do not. Although that I don't know that you're going to like those better, actually. Okay, so what I did, these all have a positive A value and they all have degree 3. And let's make sure that makes sense to you guys. So these have two things in common. They all have a positive A because they're all traveling uphill over time. And they all have 3 directions. Can you guys see the 3 directions in all of them, even the bottom one? Remember, we count that across as a direction. Okay, so these are all the possibilities for a cubic. What we're going to do is mark the real roots and then describe. So start with this. First of all, we need to know that these are all degree 3. That's very important for making sure we have all the answers. Okay, so gonna grab my other color. This first one, 1, 2, 3. 3 dots on the x-axis, 3 single real roots. Okay. Second graph. Here and here. Okay. What is this guy here? 1 single real root. And what's this guy? Yep, 1 other. Does this count as a total of 3? Yes. So I have 1, 2, 3, 1, 2, 3. Okay, now this guy. This guy's just passing through, so that's 1 single real root. There's nothing else on the x-axis, so the other 2 have to be complex. 2 single complex roots. Okay, last one. What is this thing? Triple, okay. 1 triple real. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Any questions here? I think that this is where the word imaginary came from, by the way, because they're not like actual dots. I think imaginary is a really bad word for it, but if I had to guess why they chose the word imaginary, it would be from this. Okay. Anyone still writing? Please raise your hand if you're still writing. I can give you more time. It's totally fine. Okay. Right. Good news is you're done graphing. But I don't know if you're gonna like this better. So we will see. Okay. Now, I don't know, I filmed it. Okay, So I want you to look at the original problem and notice that it's a cubic. So how many roots should it have? Three, has to have three roots. Some really, really smart person factored it for you. So the top line is the standard form and the bottom line is the factored form. You guys don't know how to factor a cubic. Guess what I'm teaching you next week? How to factor a cubic. Okay, and it's not a big deal. It's just a box. It's just like the box, like diamond and box kind of, but for a cubic. It's not bad, I promise. It's actually kind of fun. So we should get three roots out of that. And the first one is easy. They gave us x minus 2. So x minus 2 equals 0. Add 2 to both sides. X equals 2. There's one of your roots. Easy. It's 2. Okay, this guy. X squared minus x plus 1 equals 0. Okay, now I need to try to box and diamond it, but I fear it's not going to work. But I'm going to give it a go. Okay, so x squared in the first box, 1 x squared negative x. Does anything multiply to be x squared and add to be negative x? No. Sad. What do we do when we can't factor? Quadratic formula. Oh, yay. X equals negative b. That's actually going to be a positive. Hold on. Perhaps I should have written the formula out. Perhaps I should find my whiteout. It's over here. Negative b plus or minus square root b squared minus 4ac all over 2a. That's why box and diamond didn't work. Okay. So what is the description of the root situation here? First of all, what's the degree of the problem? 3. How many roots should there be? 3. What's this guy? The original guy over here. Single, real. And these two guys? 2 single, complex. Do you see where I'm getting at? Over here. So 1 single real root, that's the 2. And then these two guys are 2 single complex roots. Oh, I have to tell you, this is probably the only time that I'll ever write the quad formulas separate from each other. I usually leave it like this, but I really wanted to drive home the point that they're single because they're different from each other. But from now on, I'm just going to leave it plus or minus. Okay. Any questions about 74? We have one more problem and then we're done. So this has the same directions. Okay, here we go. Number 75, last problem. First, I have this in the front. This is factored. What type of factoring? GCF, but it's still factoring. This one is x equals 0, which is one single real root. Okay, is this factorable? Can I box and diamond that? I don't think so. I think unfortunately we're back to the quad situation. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative 1 plus or minus the square root of 1 plus 4 this time. The big difference in this problem, it's 1 plus 4, not 1 minus 4. Okay. Now, if I don't write them separately, can you tell that they're single because one is plus and one is minus? Okay, so my next question is, are they real or complex? I heard both. Complex ones need to have an I. Does this have an I in it? Nope. Are they gross decimals? Yes, but they're still real. They would still be dots on the x-axis. So this is 2 single real roots. So you have in this problem a total of 3 single real roots. So I really wanted to hammer home the difference between just a weird root or a weird root with an I in it, making sure that you know that the degree has to match the number of roots. And there's different ways you can get to that degree, but that's basically it. What's the homework tonight? Yep, 3 problems, 77 to 79. If you guys, so I'm going to stop the video. If anyone has any questions on the quiz review that you want answered individually, please come on over.